Hi students, welcome back to Smarter Everyday Over Learning. Dear students, in this session we have to learn about balancing the chemical equation by using hit and trial method. Okay? In this hit and trial method, what are the steps we have to follow? Those everything you will learn in this session. Okay? Let's see the first point. Here, write the correct chemical formulae of the reactants and the products. About these words you have to know. What about reactants and products? If you see the chemical equation, A plus B gives rise to C plus D. Okay, this is the chemical reaction, so chemical equation. Now, these two are the reactants and these two are the products. After completion of the chemical reaction, what we should get, those are known as products. And the substances which are participating in the chemical reaction, which undergoes a change, is called as reactants. Okay, that is the difference between reactants and the products. And coming to hit and trial method, the first point is you have to write the correct chemical formulae of the reactants and the products. Okay, actually this hit and trial method is the simplest method to balancing a chemical equation. Okay, and this is also called as, the first one is called as trial and error. Trial and error method, also known as hit and trial method. Many of the chemical equations can be balanced by this method. There is no definite rule for this balancing of a chemical equation by this method. At some rules, just I have to share with you. First one is correct formula. Write the correct formula of the reactants and the products. Okay, and with the plus sign between here. For suppose two or more. For suppose just like this, HCl plus NaOH. I'm going to write here. Okay, these two are the reactants. I'm differencing with the plus symbol these two reactants. So here what is the use of this plus symbol? Means if there is one or more reactants are present in this chemical equation, we have to separate them with this plus sign. And here what are the products? Some salt plus water. Okay, in between reactants and products with an arrow, the pointing from the reactants to products. This is called as skeleton equation. Okay, we have to write first of all with the correct chemical formulae of the reactants and the product, the skeleton equation. Now step number 2, select the biggest formula from the skeleton equation and equalize the number of atoms of each of its constituent elements. Okay, first of all, here the number of atoms present in the reactant side must equal to the number of atoms present in the product side. According to law of conservation of mass, these two atoms should be balanced. So these two should be in a equal number. Okay, now select the biggest formula from the skeleton equation and equalize the number of atoms of each of its constituent on the both sides of the chemical equation by the suitable multiplications. With any number, any integer number, you have to do multiply with that reactant as well as the product. Now, or in step 2, what you have to do, balance the atoms of that element which occurs at the minimum number of places on both sides of the chemical equation first. Atoms which occur at maximum number of places are balanced last. First of all, the minimum means least number of atoms places on the both sides in the chemical equation, you have to balance them first. After that, the maximum number, you look after that maximum number of the atoms. Okay, coming to point number 3. Here is the point number 3. When an elementary gas, nothing but diatomic gas, just like hydrogen, oxygen, chlorine, nitrogen, and appears as a reactant or a product, these diatomic molecules appears as a reactants or product, the equation is balanced more easily by keeping the elementary gas in the atomic state. The balanced atomic equation is then made molecular by multiplying the whole equation just by 2. If there is a presence of elementary gas, nothing but diatomic molecules like this. For suppose, while balancing the chemical equation, the chemical formula of any compound, reactant and product must be changed for sake of convenience. It is further important to note that an integer placed in front of the chemical formula, multiplying every atom of that formula by integer, thus 2NH3 means 2 atoms of nitrogen and 6 atoms of hydrogen. Why? Because here like this 2 3s 6 atoms of hydrogen. And for suppose 3H2O means that indicates 6 atoms of hydrogen and 3 atoms of oxygen. Okay, now let's see this hit and trial method with some examples, then you can understand easily. Here we have example number 1, magnetic oxide, nothing but Fe3O4. What is magnetic oxide, students? Red crystalline, here I am going to write here, red crystalline insoluble oxide. That is nothing but magnetic oxide. When heated with hydrogen is reduced to iron and water is also produced. Write the chemical equation for this chemical reaction. Okay, now we have to write for this a balanced chemical equation. First of all, the reaction is magnetic oxide plus hydrogen, nothing but H2 hydrogen gives rise to iron plus water. So this is the equation they have given in the question itself. Now the skeleton equation for this, let's write Fe3O4 plus hydrogen symbol is H2 and iron symbol is Fe plus water molecular formula H2O. You know that very well, H2O. Now the equation contains hydrogen as an elementary gas. This is diatomic molecule as an elementary gas, and it is taken in the atomic state. Okay, if you take this diatomic molecule in the atomic state only, then you can write like this: Fe3O4 plus only H gives rise to Fe plus H2O. Okay, now here the order of the selection of atoms for balancing. First of all, we need to balance iron, after that oxygen, after that hydrogen. This is the order of balancing this chemical equation. In step number 1, we have to do the equalize, just to equalize the number of atoms. Equalize the number of atoms of iron and oxygen on both sides. Just this is the equation, just to balance, just to equalize the number of atoms of iron and oxygen on both sides. Just multiply this iron with 3 and H2O by 4. Why? Because here 3 atoms of iron and here only 1. Here oxygen means here 4 atoms, so you need to multiply Fe by 3 and H2O by 4. Then the equation, which type of equation we should get here, students? Fe3O4 plus H, then 3Fe plus 4H2O. Right, now this is step number 1. Now in step number 2, the above equation has 8 atoms of hydrogen. Here 8 atoms of hydrogen on RHS. Here is the RHS, so here is LHS. Okay, you need Now in this reaction, in LHS and RHS, you need to count the total number of atoms. Coming to LHS, iron, oxygen and hydrogen. Here also same, iron, oxygen and hydrogen. Okay, you can see here iron atoms are 3. Coming to RHS, here also same, 3. Coming to oxygens, here 4 atoms are presented. Here students 4 twos. Sorry, this 4 belongs to this O also. Then 4 oxygens. Coming to hydrogens, here only 1 hydrogen, but here 8 hydrogens. Okay, so equation is not balanced here. Now students, what you have to do, that is in step 2, in the above equation it contains 8 atoms of hydrogen on RHS as against 1 on LHS. To equalize the multiply H atoms by 8 and convert it into molecular state as 4H2. Now we have Fe3O4, same, Fe3O4 plus 4H2, again same, 3Fe plus 4H2O. This is the required balanced molecular chemical equation. Okay, now students, if you count the total number of atoms here iron atoms are 3, here also 3, so Fe is balanced. Here coming to hydrogen, 4 twos 8, here 4 twos 8, hydrogen also balanced. Coming to oxygen, here 4 oxygen atoms and here also this 4 belongs to this entire compound, so 4 oxygen atoms. Totally iron, oxygen and hydrogen, 3 elements are balanced. So this is the complete balanced equation. In second example, acetylene burns in oxygen producing CO2, carbon dioxide and H2O. Write the balanced chemical equation for this reaction. Okay, now acetylene burns, that means it is a combustion reaction. Let's write the chemical equation for this. Now the reaction is acetylene plus oxygen. Acetylene plus oxygen gives rise to what they have given, carbon dioxide and water plus water. Now the skeleton equation for this, acetylene formula C2H2 plus oxygen gives rise to CO2 plus H2O. This is the skeleton equation. First of all, you have to write the skeleton equation for this. To start with, the elementary gas is oxygen appearing in the above equation is written. It is written in the form of atomic state. Now we have C2H2 plus O, CO2 plus H2O. Okay, only this is the atomic state of oxygen. We have represented like this. Now students, here the order of the selection of atoms for balancing is carbon, hydrogen, oxygen. In this order, let's balance first of all the carbon elements and the hydrogen, and the third one is oxygen. For in first step 1, to equalize the number of carbon atoms, multiply CO2, multiply this CO2 by 2. Okay, now we get the chemical equation. Now we have C2H2 plus O gives rise to 2CO2 plus H2O. Here this CO2 just we can multiply with the number 2. Then we got this equation. Second point, the number of hydrogen atoms. Is same on the both sides. This is LHS, this is RHS. So here hydrogen atoms 2, here also 2. Now the number of hydrogen atoms in the both sides is same, but there are 5 atoms of oxygen. Here 2 2s 4, 4 plus 1 5. 5 atoms of oxygen in RHS as against 1 on LHS. Hence multiply the atom. Now multiply the atom of O by 5 on this LHS. Now we have C2H2 plus 5O. Okay, now if you multiply this oxygen by 5, then you should get like this, and it is same to CO2 plus H2O. Now it is a balanced atomic equation. Now in the third step, what you have to do, multiply the whole equation by 2 to convert it into a molecular equation. This is the atomic equation. Then just to convert this into molecular equation, you need to multiply with whole equation just by 2. Now you should get like this: 2 C2H2 plus 5O2. Now 4 CO2 plus 2 H2O. Right. This is the required balanced molecular equation. Now let's check it once. Here carbon atoms, LHS, this is LHS and this is RHS. Carbon atoms and hydrogens and oxygens. Here also same, oxygens. We need to count how many are presented here. Coming to carbon atoms, here 2 2s 4 carbon atoms. Here also same, 4 carbons. Now hydrogens, here 2 2s 4 hydrogens, and here if you see 4 hydrogens. Coming to oxygens, here students 5 2s 10, and in the reactant side oxygens are 10, that is about LHS, and coming to product side oxygens are 4 2s 8 plus 2. Here also same, oxygens are 10. Now this equation is balanced. Now in the question, acetylene burns in oxygen producing CO2 and H2O. This is the balanced chemical equation. Okay, let's go for the third example. Balance is a given skeleton equation. Mg3N2 plus H2O gives rise to MgOH twice plus NH3. So just to balance this equation, the various atoms are balanced in the order of magnesium and nitrogen and hydrogen. In this order we have to balance this equation. Now first of all, in the first step, step 1, to equalize the number of magnesium atoms on the both sides, multiplying MgOH twice by 3. Now we should get Mg3N2 plus H2O gives rise to 3 MgOH twice plus NH3. This is the first step. Coming to step number 2, to balance the nitrogen atoms, multiply NH3 by 2 on the RHS. This is only RHS. Now we should get Mg3N2 plus H2O gives rise to 3 MgOH twice magnesium oxide plus 2 NH3. Okay, this is step number 2. Now in step number 3, to equalize the number of hydrogen and oxygen atoms on the both sides in the above equation, multiply H2O occurring on LHS, H2O of the equation by 6. Now you should get Mg3N2 plus 6H2O gives rise to 3 MgOH twice plus 2 NH3. Okay, now this is the required balanced chemical equation. Now let's check it once. Both sides, this is LHS and here it is RHS. Coming to the number of atoms, the total number of atoms presented in the reactant side and the product side, let's check it once. Here magnesium atoms and here also magnesium, and nitrogen, hydrogen. In the reactant side, the number of magnesium atoms 3. In the product side, here also same 3. Now magnesium is balanced. Now coming to nitrogens, here 2 atoms of nitrogen and here also 2 atoms of nitrogen. 2, 2. And hydrogens, see here 6 2s, so 12. Here also, that means 3 into 2, 6 plus here 3 into 2, 6. So hydrogens also 2. Okay. Now students, this equation is balanced. Now in the question, balance the given skeleton equation. Mg3N2 plus H2O gives rise to magnesium hydroxide plus NH3. Okay, this is the complete information of heat and trial method. What are the steps we have to follow and what are the examples? How we can write the correct chemical formulae of the reactants and the products, and in which way we have to balance the entire chemical equation. Okay, the complete steps. Okay students, what is your opinion? You have to convey in the comment section. If you understand this class, you can subscribe to this channel for my further updates. Thank you so much. Thanks for watching.